like a visual and the actual definition. Okay, I'm going to use the letter K when I write these definitions down today. And it's very important because if it's not, it's going to be a special case. So in this little definition I'm going to give you, the K value, it's going to represent a number, and it has to represent a positive real number. It cannot be a negative. If you have an absolute value by itself and it's related to a negative number, if it's, bless you, if it's an equation, it's going to be no solution. If it's an inequality, it's going to be a special case. I'm going to go over the two types of those today with you guys here in a second. So for the moment, we're just going to assume that K represents a positive number. Okay, here's how this works. To drop the absolute value, like if we had the equation, we'd get the absolute value by itself, we would drop the absolute value, set it equal to the number and the opposite of the number. It's going to be kind of a similar process with an inequality. So this is X, absolute value by itself, greater than or equal to, this would also apply to just a plain greater than, some number. And I remember this as great or, and I'll show you that in a second. Like this is greater than or equal to or greater, either one. It's going to be an or statement when we put it on the graph. The two little arrows are going to point away from each other. That's why I'm going to write that down. So what you do here, drop the absolute value, and you're just going to copy whatever's inside the absolute value is going to be greater than or equal to that number. Or, again, just drop the absolute value, just copy whatever's in there. For the definition, I just have X. And then what you're going to do, you're going to flip the inequality symbol to go the other direction, so less than or equal to, excuse me, and then the opposite of whatever that number was. So I used K to represent the number. I'll give you one with actual numbers, and I'm going to show you what it looks like on the number line here in a second. But this is going to be what we call compound inequality. These are going to point away from each other on a graph. Okay, so let me just give you a little tiny example that's got a number. So I have X is greater than or equal to 3. So I want you to think about this for a second. So I'm going to drop my absolute value. I'm just going to follow that definition and say X could be any number greater than or equal to 3, right? And I'm going to come over, I'm going to just put this on a graph here real quick. So would I have an open circle or a closed circle at the 3? Closed. If you see it, it's solid. That's how I remember it. So it's underlined there. So numbers bigger than 3. Right? Like 4, 5, 6, 7, that makes sense. So as I go to the right there, I'm like 6, 7, 8, 9. Those are all numbers that are bigger than 3. Okay, now, when you're working with an absolute value, if it's greater than, which it is, I'm just going to write or really quick. And what I'm going to do, I'm going to copy that exactly how I saw it, just the X. I'm going to flip the inequality symbol to go the opposite direction. And then I'm going to also write down the opposite or just flip that number to be -3. Now I know this is a little bit weird, but think about this with me for a second. So I'm going to have a lovely little closed circle at -3. We are talking about numbers that are greater than or equal to 3, but that I have that X is in an absolute value. If I were to plug in like -4 to that absolute value, the absolute value, remember, makes everything positive, so it would cancel it out. So like -4, -5, -6, all those negatives would get canceled by the absolute value. So you have a whole bunch of numbers going to the left that would also satisfy that inequality. Does anybody have any question? Okay, now obviously we're going to work on some that are a little bit more complicated here. So let me write the interval notation real quick. I just introduced that yesterday in the little flex day video, but I'm just going to write an interval for this. Okay, so this is X is less than or equal to -3. To write your interval, this points to the left forever. So just for this little arrow, this would be -infinity, because it goes to the left forever, and then I'm going to stop at that -3. Since I got a filled in circle, I just put a little bitty bracket. That means I actually include the -3 as part of our answer, so we're good there. And then we put this little symbol here, just a little union symbol. It just means both of these are going to work for our answer. Okay, whenever you write the interval notation, start with the smallest possible value. So if I'm looking at this arrow, I'm going to have a bracket with a +3. That guy points to the right forever, so that would go all the way to +infinity. whenever you have an infinity symbol, it never has a bracket because it's not a specific value. We can always get smaller or bigger with positive infinity or negative infinity. Okay, now I'm going to apply this definition here. You want to get your absolute value alone, which for this very first question, I already have that going on for us. So we're going to solve and graph this real quick. I'm going to drop the absolute value, just copy it exactly how you see it, but just no absolute value. And then I'm going to write, or, if this one's just a plain greater than, so when we get our graph going, we'll have a little bit different thing with the circles, but copy that exactly as you see it, the x minus 5 over 4. To write the other half of this, you're going to take the inequality symbol, just flip it over, so now this will say less than, and then you're going to flip that number too. So this was a positive 3, I'm going to now change that to negative 3. All right, now to put this on the graph, I would literally just kind of break these, just solve them as like two separate problems right there. So if you had, does anybody know what to do if you got, I've got x minus 5 over 4 is greater, or yeah, just greater than 3. I'm going to try to get x by itself on one side. How would I do that? Like, what would you do first? Yeah. Multiply by 4. Just get rid of that fraction. Just real quick, just multiply by 4. All that's going to do, just gone right here, and you're just going to have x minus 5, and then 3 times 4 is going to give you 12. You just add the 5, and you're done. So any number, if I take 12 and 5, add those guys up, I'm at 17. If I can pick any number bigger than 17, that's going to work on the positive end. And I would do the same thing. The algebra usually looks really similar, but you're going to get probably different numbers unless it's a weird situation. So I'm going to multiply by 4 again. This time when I do it on the other side, I'm going to get negative 12. And I'm going to do the same thing I did on the last one. I'm going to add 5, but I'm going to get a totally different answer. Any x value, this is going to be less than negative 7. And then just remember, this is an or statement, so these two things should point away from each other. The half that goes to the right, those would be numbers that would be strictly greater than 3 if we plugged them in for the x value. On the other end, it's going to be less than negative 3, but it's going to actually satisfy our inequality because the absolute value will cancel the negative out. Now, you don't have to do some elaborate graph here. Just grab these two numbers. So negative 7 should be somewhere on the left side, and the 17 should be somewhere on the right side. It does not have to be perfectly spaced or anything. One of the arrows should point to the left, one of them should point to the right. So if I've got the 17, this says x is greater than 17. At 17, would you have an open circle or a closed circle? Leave it open, so 17 is not part of the answer. Any number bigger than that, so like if we plugged in 18 or 19 or 20 or whatever, those would all make that inequality true. On the other end, this other inequality we have reads x is less than negative 7. So less than, open circle again, this is going to go to the left. Any number smaller than negative 7, if we plug that back into that original problem, we're going to have a value that will be negative, but that absolute value will be canceling out the negative number. So all those numbers to the left would also work. If you're doing a graph of these, both of your circles should either both be open or both be closed. You shouldn't have one of each whenever you do any of these absolute value inequalities. Okay, now I'm going to practice one more with you here. Now, the challenge is you cannot apply that definition unless you have that absolute value all by itself. So you got to make sure you get the absolute value alone on one side first. So in this, I have absolute value 1/2 x plus 3. Just kind of treat that as a giant variable. I want to get that by itself. So I have 4 times that absolute value, and then minus 10 greater than or equal to 54. If I'm trying to get that absolute value alone, what should I do first? Yeah. Add to 10. Perfect. Add to 10. Don't divide by 4 because you'd have to divide everything, including the 10 by 4, and that would be annoying to work with. All right, so add the 10. Get rid of any addition or subtraction that you can first. You cannot add and subtract things out of the absolute value. You want to get the absolute value just alone. Okay, another tiny review from the other day. Do not ever distribute anything into an absolute value. Don't distribute. You got to get rid of that 4. We're going to divide. Now, I'm just dividing by positive 4, so we're not flipping any signs or anything like that. I'm going to get 1/2 x plus 3. And then this is a nice number. If you take 64 divided by 4, you're going to get 16. All right, once your absolute value is below, you're going to apply that little definition. So, absolute value all by itself, right? I'm going to drop the absolute value and just copy just exactly what I see. I'm just going to write down 1/2 x plus 3 greater than or equal to 16. All right, now, greater means my other inequality is going to be an or statement with this. So these should point away from each other. I'm going to copy it down, that 1/2 x plus 3. What you're going to do, you're going to flip the sign and flip the number. So it should be 1/2 x plus 3 is less than or equal to, the opposite of that number is just going to be negative 16. Okay, now again, both of these, when we solve them, they're going to be similar algebra steps, but they should give us different numbers as we go through here. So if it was me, for sure, I'm going to subtract 3. I'm just going to do it on both of them at the same time as my first step. I'd get 1/2 x greater than or equal to 13 on that first one, or 1/2 x is less than or equal to, now if I got negative 16, subtract 3, we're getting more negative, so that would be negative 19. Okay, how would I get rid of the 1/2? Times by 2. I would just multiply by the reciprocal, just flip that over, times 2 on both sides, multiplying everything by 2. I'm just kind of working them both at once. So that's not flipping any inequality symbols over or anything like that. I'm just multiplying by positive 2. 13 times 2 is going to give you 26. So this is saying any number greater than or equal to 26. That would give us numbers, if I'm looking at this inequality, strictly bigger than 16, like 17, 18, 19. On this side, you'd have x is less than or equal to, I'm going to get a negative number here, but I don't flip the sign because I multiplied by positive 2. It's okay to just go ahead and leave that. That would be 38, negative 38. Now, if you put this on the graph, these should point away from each other. All right, so I'm going to put the negative 38 somewhere on the left. It doesn't have to be perfectly spaced or anything like that. And the positive 26 should be somewhere to the right of that. Okay, both of these circles, when I put them on here, are they going to be open or closed? Closed, right? Okay, because I've got a greater than or equal to, less than or equal to. So 26 is a possible answer. Negative 38 is also a possible answer. Now, if you look at these inequalities, the x is greater than 26, that arrow points to the right, so that should go to the right. Any number bigger than 26 is going to work. This one, x is less than or equal to negative 38. As I do that, that arrow points to the left, so any number smaller than that. Whenever you do a greater than absolute value inequality, they should point away from each other. And I'm just, as I'm doing this, let me write the interval notation for you guys for both of these just so I can show you that. So on this one that we just did, this goes to the left forever to negative infinity, and it stops at the negative 7. But the negative 7 has an open circle, so it's just a plain parenthesis because negative 7 is not part of the answer. And we have another little arrow going to the right. That starts up at 17. Goes to the right forever, so that's going to go to positive infinity. So you're saying any number between negative infinity and negative 7 would work. Also, any number between 17 and positive infinity will satisfy that example we did just a couple seconds ago. The one we just did would look very similar, negative infinity to negative 38, but this guy would have a bracket because the 38 has a filled-in circle, so 38 is one of your answers, and then just this little union symbol in between. It just means there's two different sets of numbers that'll work. And this will be 26 positive infinity. So whenever you do a greater, you've got or statement, so they're going to point arrows away from each other. You have two intervals that you want to write down if they ask you for the interval notation. Is anybody having a question? Okay, now at the very bottom, I'll give you this special case. And it doesn't look like it to start out, but I promise it is. If I was going to get my absolute value alone here on this problem at the bottom, what would I have to do? I've got -3 times my absolute value less than or equal to 30. What would you have to do if you're trying to get it alone? Okay, perfect. Now, what do I have to do if I'm working with an inequality symbol and I divide by a negative? We got to flip the sign. Okay, don't forget that. Divide by a negative, you're going to flip the sign. Okay, so once I have my absolute value by itself, this is now going to be greater than or equal to, because I divided by that negative number, -10. Okay, now, remember I told you at the top, that absolute value has to be related to a positive number. Then we can apply the definition and do what we just did. If it's related to a negative number, we're going to have a special case. Okay, so it doesn't matter what's in here. Doesn't matter what it's in here. What does an absolute value do to every number? Makes it what? Positive. Okay, so here's what I have. I have some positive number, I don't know, is greater than or equal to -10 in this case, but I'm just going to write, I have a positive number greater than or equal to a negative number. True or false? This throws people off sometimes because of the or equal to part. But a positive number always is bigger than a negative number. It's never going to be equal to it, but that's okay. It's greater than or equal to, so a positive number always greater than a negative number. So no matter what I plug in for x, this will always be true. If that's always true, what do you think my answer would be? All real numbers. Okay, now, if you want to just write that all real number symbol, I think I talked about that on the notes yesterday. If you want to do an interval for all real numbers, it literally covers the whole number line. The interval from that goes from -infinity to +infinity. And if you're asked to do a graph, it's literally the whole number line. So the graph in that situation would literally just be like, I'm just going to put a whole nother number line on top of it, because I could pick any number I could think of and it would make that inequality true. Is anybody having a question? Okay, all the ones on the front were greater than. When I flip over to the back side, all the ones on the back side are going to be less than. And honestly, the greater than ones I think are a little bit longer. The less than ones are a little bit quicker to do. Okay. So again, I just wrote this so you guys have this and so you look at these definitions. I'm going to use that letter K again. And if you want to apply this definition, K has to be a positive number. If it's not, we're going to go over that at the bottom of the page on this side too, just like we did on the front. Okay, this is going to work the same way, but I call these less than when we do these. These are going to be an and statement. When you create these absolute value inequalities that are a less than or equal to, they're going to point together on the number line, and you're just going to have a line segment basically when you graph these. Okay, so here's the actual formal definition. If absolute value of x by itself less than or equal to a positive number, you're just literally drop the absolute value and copy that as it appears. Now this is the main difference here. This is going to be and. Same thing we did on the front. You're going to flip the sign over and write the opposite of whatever that number was. The main difference here is these are going to point together when you put them on a graph. So as my example here, I just put a little number line so we could talk about this here. All right, by this definition, it says absolute value of x is less than or equal to 3. So x is less than or equal to 3, and meaning it has to satisfy both of these inequalities. X is greater than or equal to -3. It's going to run between these two values is what it's going to do. So if I got to be smaller than 3, think about this. Here's 3. I'm going to close my circle up because it's an or equal to for this definition. Here's -3. Close this circle up. Okay. Now, the -3 would point to the right from there. the positive 3 would point to the left if you look at those inequality symbols. So if I'm graphing this properly, I should just play connect the dots here and make a line segment, but you don't go outside of that. So all these numbers here on this little segment, those are smaller than 3. Once I get outside of that, right, if I plug in 4, 4 is not smaller than 3. 5 is not smaller than 3. On this end, if you plugged in negative 4, that absolute value would cancel it out, and then you'd have 4 is less than 3, or negative 5. If I plug that in, I'd have 5 is less than 3. That's not true. So it's just going to be between those two. Now, the interval for these is way easier too. You're just going to have one interval, and I'm going to have brackets on both ends of this. You're just going to write me those two numbers. So this one would just be all the numbers from negative 3 to 3. Would have a bracket because I have filled in circles, and negative 3 and 3 would both actually be solutions here. So these are a little bit easier to work with. They're just going to point together. Okay, so isolate your absolute value is your first step. So I have absolute value of x minus 6 plus 3. So plus 3, I'm going to subtract 3 to move that to the other side. Absolute value of x minus 6 is less than, and I would have 15 there. Once I'm there, I got my absolute value all alone. And then I would break it apart into that definition from the top. Okay, so I'm just going to drop the absolute value, copy it exactly. And the only difference here, if it's less than, this is going to be an and statement. These are going to point towards each other. I'm going to copy that down, x minus 6, what was in your absolute value. You're going to take that symbol and you're going to flip it over. So this would be x minus 6 is greater than, and then you're going to write the opposite of that number, which would just be negative 15 for this example. Both of these, I'm just going to solve at the same time. All I'm going to do is add 6. All right, on the one I wrote first, it's going to be x is less than 21. And it's got to work for both of these. X is greater than, what would that be? Negative 9. Okay, so x is going to be between those two values. Anytime it's a less than, it's an and statement. They're going to point together. So I'm just going to do somewhere on the left side, put that negative 9. Somewhere on the right side, put that 21. They don't have to be perfectly spaced or anything like that. All right, both of these circles will be open or closed? Open. All right, so not included as part of our answer. Now, greater than negative 9 would point this way. Less than 21 would point to the left, and so we're just going to play connect the dots in between. It doesn't go outside of there. If it goes outside of there, whatever number, like if I plugged in 23, that's going to end up being bigger than 15 if you plug that into that inequality. To do your interval, super easy here. Just these are parentheses because the numbers are not included. The smaller number on the left, the negative 9, larger number, which is 21 on the right, then you're done. That's it. Less than, they point together. Greater than, we did that on the other side, those point away. Okay, and then I'll just do one more with you real quick. So this one's a little more complicated to get by itself here. So I have 3/4 times my absolute value, and then I got 2x plus 3 minus 5 equals 1. What should I do first there if I'm trying to get the absolute value totally wrong? Add the 5. Don't deal with the fraction yet. Get rid of, if you got something to the side there, get rid of any addition or subtraction that you can first to the side of your absolute value. Otherwise, you're going to have to mess around with the 3/4 and the 5, and we don't want to do that. All right, so I've got 3/4, 2x plus 3, and less than or equal to 6. Okay, does anybody know how to dispose of the 3/4? How do I get that away? Yeah, you could do this, you could do it like one thing at a time. You could multiply by 4 and then divide by 3, or you could do it all in one step. Just flip that fraction over. If you multiply by a reciprocal, right, if I actually did it over here, we'd get 12 over 12, which is 1, which cancels it out. So if I multiply both sides just by the reciprocal, on the left, it's just going to cancel that fraction out. We're not going to have it anymore. So this would be 2x plus 3 is less than or equal to, and you guys can use a calculator if you want, or I'm just gonna go over here to the side by hand. Now, think of that 6 as 6 over 1. Do not need a common denominator to multiply a fraction and a number together. Just straight across the top, straight across the bottom. This would be 24 over 3, which actually is going to give us a nice number. That's just 8. Okay, once you're there, we got our absolute value alone. Then we can apply our definition. If it's a greater than or equal to, we're going to have an or statement. This one is saying our absolute value is less than or equal to 8. So this should be an and statement. These should point together. So I'm just going to copy that down. 2x plus 3 less than or equal to 8. Less than. So this is an and statement. Has to work for both of these. Just copy it down again. Just drop your absolute value. Flip the sign and flip the number. So the inequality symbol goes the other direction, and then the number becomes the opposite. So I have 8 at the beginning. When I flip it over, it becomes negative 8. All right. Now, I don't necessarily think these are going to be nice numbers here. So I'm going to subtract 3, and I'm going to get 2x is less than or equal to 5 here. On this one, I'm going to get 2x is greater than or equal to negative 11. Now, completely up to you guys. If you like the decimal or a fraction better, both of these I'm going to divide by 2, but I'm just going to write the decimal. I'm dividing by positive 2, so we're not flipping any signs over or anything like that. This one would be x is less than or equal to 2.5. And this one would be x is greater than or equal to, what is that, negative 11 over 2, negative 5.5. On the screen here. Okay, now I am going to put the negative 5.5 just somewhere on the left, doesn't matter. But that should be smaller number, so we're going to put that on the left. Positive 2.5, just put it somewhere. Doesn't have to be perfectly spaced or anything. On the right. Okay, both of these, one's less than or equal to, one's greater than or equal to. So I'm going to have filled in circles here. And we're just going to play connect the dots because I'm going to be greater than the negative 5.5, so that one would point to the right. Less than the 2.5, that would point to the left. And to work for both, we're just going to play connect the dots. Anytime it's a less than. The interval is super easy here, but this one would have brackets on both because the actual values we got are solutions here. Negative 5.5 and 2.5, just with brackets around it. That would be the interval notation. And that's all you have to do. Does anybody have a question? Okay, let me give you the last one. Now, remember, I did this with you guys on the front, too. This is going to be a special case. All right, in my attempt to get the absolute value alone here, right, I got to get rid of the negative 2 that's being multiplied in front. So to do that, we're going to have to divide. Now, when you do that, you got to remember, if you divide both sides by negative, you automatically have to flip that sign over. And 58 divided by, oh my goodness, my brain's not functioning. I think it's 29, is that right? Yep, okay. Negative 29, oops. Negative 29, sorry, I can't write. Okay, now here's the deal. I have absolute value and it's by itself, but it's related to a negative number. Cannot apply the definition that I gave you guys at the top, okay? If it's related to a negative number, it's going to be a special case. Okay, just like on the front, remember absolute value, no matter what, is going to make anything I plug in there for x a positive number. So what I have here is a positive number is less than or equal to some negative number. For this little particular example, it's negative 29. So is a positive number less than or equal to a negative number? No way, this is never true. Like no matter what number you plugged in here for x, this would always be a false statement. Positive number can never be, it's never going to be equal, but it's definitely not less than a negative number. So this is false. There's no graph, there's no interval, there's nothing here. This is not true. So this situation, if you get an absolute value by itself less than or equal to a negative number, that's not going to have any solution you can use Can't find any x value that you would plug in there that would ever make that true. Okay. And then there's no